Now I'm going to be dealing with indices, 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 indices. So as you all know that indices is the plural form of index, which is refers to as power. Sometimes you call it power, you call it indices, index. So now, in handling indices, you have some rules that once you are able to master those rules, you know those rules, then anywhere, any day, anytime you see indices question anywhere, you'll be able to solve it easily without not getting a wrong answer. So the first one I'm going to be dealing with now is multiplication rule. What the multiplication rule says that if you are having a raised to power n times a raised to power n, it will give me, so this is where the rule comes in. So for you to apply the rules, must have the same base. So since I'm having the same base, I will pick one because of they have the same base. So I'm picking one. So the first a is having m. Now for me to get the second a, there is a sign here which is multiplication. So it says that whenever I'm having multiplication as a base reaction here, then the power is going to be addition. And you see it now. I mean, when you say a times a, you will be having m plus n. So which means if I have a raised to power 3 times a raised to power 2, so what does it say? It means that a raised to power what? 3, because of multiplication, to become plus 2. So at the end of the day, I have a raised to power 5. So now another one I'm going to be dealing with is the division rule. The division rule. So what does the division rule say? The division rule says that if I'm having the same base, a raised to power m divided by a raised to power n. So since they have the same base, so I'm going to pick one. So if I pick one, it means that I will now say m, because of this sign here, division sign, it means that to the power, I'm going to be what? Subtracting it, n minus n. So this is the answer. So which means if I'm having a raised to power 3 divided by a raised to power 2, so it will give me a raised to power, the first one is 3. Because of this sign, I'm going to apply what? Minus. So minus 2. At the end of the day, I have a raised to power 1, which is what? Equals to a. So that is another one. So another one I'm going to be dealing with now is when I have a raised to power 1 over anything. It could be n, it could be any alphabet, so any variable. Then it means that this the power, this denominator here, it will now become the root of the base, which is a, while the numerator here will now become the power. So what do I mean? It means that a now is now the root of n all raised to power 1. So that is what it means. So which means if I have this one here could mean anything. If I have 2 over n, it means that a is a root of n, then all raised to power what? All raised to power 2. So I hope if you don't get it, watch the video over and over, then you'll be able to grasp, because later on we are going to be applying each of these rules to solve question. So another one I'm going to be talking about is when you have a, I've solved this one, a over n. So it means that for me to deal with this one, it means that root of a is a root of n all raised to power what? M. That's all. You see, 1 or 2 steps, you are done. So another one I'm going to be dealing with now is when you say a raised to power minus anything, minus 1, minus 1000, minus anything you can think of. So once you see it like that in indices, whenever the power, we are having something raised to power minus, it means that this minus alone, because it's in the power, it means 1 over. So when you say 1 over, it's like you've removed this, you've turned it to what? 1 over. So if this one is no more there, what remains? You are having a and 1. So it becomes a raised to power what? A over 1. So which means if I'm having a raised to minus anything, let's say 10, 1000, 1 million, it means that I will change to make it easier for me. I will change this one to 1 over first. Then I'm left with what? A and 10, which is a raised to power what? 10. That is that. So another thing I'm going to be saying now is that whenever you see anything raised to power is 0, is 1. Anything raised to power 0 is 1. Don't be afraid. If you see the whole world raised to power 0, just know that is what? is 1. Now we're going to be looking at some example now. Now if you are to look for a raised to power half, and somebody is asking you to what is the answer to this, so just know that, like we've earlier said, this the denominator becomes the root, while this one becomes the power. So 9 is the root of 2, all raised to power what? 1. So root of 9 is 3. Square root of 9 is 3. You see now. So now imagine if you are asked to simplify in an exam. You see something like simplify 36 raised to power half multiplied by 64 raised to power minus 1 over 3 multiplied by 5 raised to power 0. So you are applying the rules. This is a multiplication rule with the minus raised to power 1 over 3. All this one now, you just apply the rule to each of them one by one. Then you have your final answer. So this one that is 36 raised to power 1 over 2. It means that 36 is the root of 2 all raised to power 1 multiplied by, because of this minus, I will remove this one first. That is 1 all over what? 64 raised to power 1 over 3. I've turned this minus to 1 over. That is why there's no minus here again. Then times, I've said earlier that anything raised to power 0 is what? Is 1. So root of 36, that is anything you multiply 2 times to get 6. To get 36 is 6. Then times, this one becomes 1 over root of 3, because this one is the denominator now. 3, 64. All raised to power what? All raised to power 1, because I'm having 1 here. Then times what? Times 1. Then I'm having 6 times what? I'm having 1 over what is the number you multiply 3 times to have 64? I think it's 4. 4 times 4, 16, 16, 64. Yeah. Then raised to power 1. This 1. So times what? Times 1. So 3 here, you can say 2 here, 2, 3, 2 here, 2. At the end of the day, your final answer is what? 3 over 2. So which we can say is 1 over 2 is your final answer. So another one that I'm going to quickly look at is this. If you are asked to simplify, you are saying simplify 1 over 4 into 2n raised to power n minus 2 raised to power n plus 2. So in this is, you see some funny question that you will be thinking of, can you solve this quickly? Once you see, just apply the rules one by one, then you'll be able to get the final answer. So to make things easier for me, I have to open the bracket first so that I know the next step to take. So 1 over 4 times this, I have 2 raised to power n over 4. Then minus 1 over 4 times minus 2 raised to power n plus 2 give me minus 2 raised to power n plus 2 all over 4. Now, so once I have arrived here, now what I will do, you know what we've been solving earlier, the base must be equal before I pick 1. So I have to find a way of changing 4 to what? A base of 2. So now, how do I now do that? 2, you know that 2 raised to power 2 is 4. So I will continue by saying 2 raised to power n over 2 raised to power 2. That will give me what? That will give me 4. Then minus 2 raised to power n plus 2 all over 2 raised to power what? All over 2 raised to power 2. So I can now pick 1 because they have the same base now. 2. Now this one is carrying n. Because of this sign here, so I've told you that the division sign means that the power becomes what? You subtract the power from each other over 2. Is this one that turns this one to this. Then minus the same base, I'll pick 1. This one is carrying n plus what? Plus 2. While this one, the 2 down here, is carrying raised to power 2. So because of this sign also, I'm changing it to minus, and it's 2. So at the end of the day, I'll have 2 raised to power n minus 2 minus 2 cancel 2. We are left with 2 raised to power n. So this is your final answer. So last but not least, I'm going to deal with, if you see any question you don't understand, you can post it, then we'll solve it together. Then we have 9 raised to power 2 raised to power 9 raised to power 2s plus 1 equals to 81 raised to power s minus 2 over what? 3s. So don't let this one to fear you. Find s, find the value of x. So once you see it like this, just apply the rules, and you are good to go. Now for me to tackle this now I have to find a way. If you look at the numbers, they have the same trend, they are the same factor, they are factor of each other. So I have to bring it down so that I can have all of them base 3 base 3 base 3. Then I can now move on. So you know that 3 raised to power 2 will give me 9. right? And 9 itself is carrying some power, carrying a power before, which is 2s plus 1, and equals to 81. What is it that you can raise to power 3 to get 81? I think 3 raised to power 4 give us 81. Then there's power there already, which is s minus 2. Then all over what? 3 raised to power s. You see now that all of them, they are coming together, they are becoming one now. Then I can now repeat this one. There's nothing to add to this one. Then open bracket here. 2 times 2, 4x. 2 times 1 plus 1. This one is done. Then equals to, I open bracket here too. 4 times s. I have 3 raised to power 4s. 4 times minus 2 minus 8 over what? 3s. So I will repeat this one. 3 raised to power 4s plus 1 equals to, now this one now they have the same base. I cannot pick 1. So this one is carrying power of s minus 8. Because of this sign here, then this one become what? Become minus. Because of this sign, the power become minus, and it's carrying raised to power x. So that is x here. So then in indices, whenever you are an equality sign is separating two variable, or two, let's say two variable now, and they have the same base, you can cancel it out. So you are left with the power. So I'm having 4s plus 1 equals to 4s minus 8 minus x. So 4s plus 1 then equals to this minus, you have 3s minus 8. So collect terms. If this one comes here, become minus. This one goes here, it becomes minus. Sorry, I think we've made some mistake here. 2 times 1. 2 times 1. This one will give us so that I will not get the error. 2. This one will give us 2. I'm sorry. This one will give us 2. This one will give us 2. So let's collect terms. So we have 4x. If this one comes here, become minus 3s. This one equal, if this one is here, it's minus 8, and this one comes here, it becomes minus 2. So this minus this, you have s equals to minus 10. So that is your answer. So now I'm going to put a question here that will ask you to solve. If you get your answer, you can post it. Let's see if someone is following. Then I say solve this, then post your answer. Solve, then post your answer. So the question says that simplify 25 raised to power 2 over 3 multiply by put division divided by 25 raised to power 1 over 6 divided by 1 over 5 raised to power minus 7 over 6, then multiply by 1 over 5 raised to power 1 over 6. So when you get your answer, you can post it. So looking at what we have been solving this morning, you could see that solving indices is very straightforward when you know the rules. That when you are multiplying, you add the power. When you are dividing two variables, you are dividing them, and with their power, you subtract it. You have something like this. So once you just know how to play your way around, then you are good to go in solving indices. Thank you.